Hello students, Stride here again. Today we're going to look at section 4.2 called the structure of an atom. Here they start with a big tall building, 45-foot tall steel sculpture, not a building, made of 10 tons of steel. If a proton had the same mass as the sculpture, an electron would have a mass of about 5 kilograms, which would be in the neighborhood of 12 pounds or so. So, just a little relationship between the mass of a proton and an electron. We've got 3 subatomic particles. One of our key questions here, you need to know that our 3 main subatomic particles are the proton, electrons, and neutrons. Protons. Rutherford concluded that the amount of positive charge varies among elements. So experiments that Rutherford did, we got different positive charges. Then the proton is where this positive charge is coming from. Positive charge subatomic particle found in the nucleus. Each proton assigned a charge of 1 plus, and every nucleus has at least 1 proton. Thomson detected particles that were later called electrons. Electron, negatively charged particle. Negative. Found in the space outside the nucleus. Outside the nucleus. And each electron has a charge of 1 plus. Neutrons. 1932, English physicist called James Chadwick carried out an experiment to show neutrons exist. He concluded that the particles he produced were neutral because charged objects did not deflect their path. Neutron, neutral subatomic particle, neutral, found in the nucleus of atom, has a mass almost exactly that of a proton. So it's a mass about that of a proton. Another key question, what properties can be used to compare protons, electrons, and neutrons? And they can be distinguished by mass, charge, and location. Chart shows you this information. So you got the 3 particles. Give you their symbols. The symbol for the neutron, sometimes we might also see as an N with a little 0 up, indicating it's neutral. Relative charge, we need to know that. Relative mass. Actual mass put in your table here, but I won't expect you to memorize those numbers. But all of this over here, we need to know. Similarities and differences between protons, neutrons, and electrons. Protons and neutrons, almost the same mass, Takes about 2,000 electrons to be mass of one proton. Electron has a charge equal in size but opposite of that of a proton. Neutrons, no charge. Protons and neutrons found in the nucleus. Electrons found in space outside the nucleus. How are atoms of one element different from atoms of another element? That's one of your key questions. So your key responses here. Atoms of different elements have different numbers of protons. And we can identify these by their atomic number. Atomic number is the number of protons in an atom of that element. All atoms of any given element have the same atomic number. Each hydrogen atom will always have one proton as nucleus, so hydrogen is given the atomic number 1. And each element has a unique atomic number. The arrangement of the periodic table is based on their atomic numbers. Such as on the periodic table, you'll see that sulfur is element number 16. Iron is element number 26. Silver, element number 47. Atoms are neutral, so each positive charge has to be balanced out by a negative charge. It means the atomic number of an element is also equal to the number of electrons in an atom of that element. So hydrogen has atomic number 1, meaning it had one proton, so it also has to have one electron. Sulfur, atomic number 16, so it has 16 electrons and 16 protons. Mass number is the sum of the protons and neutrons in the nucleus of an atom. If you want to find the number of neutrons in an atom, you need the mass number of the atom and its atomic number. And the number of neutrons is its mass number minus atomic number. The atomic number of aluminum is 13. Atom aluminum has a mass number of 27, so it has 13 protons and 14 neutrons. Difference between isotopes. Keyword here, isotopes. Isotopes. An element have the same atomic number, they have different mass numbers because they have different number of neutrons. Isotopes are atoms. Here's the definition. Isotopes are atoms of the same element that have different numbers of neutrons and different mass numbers. Distinguish one isotope from another. They're referred to by their mass numbers. Oxygen has 3 isotopes. Oxygen 16, oxygen 17, oxygen 18. All 3 isotopes react with hydrogen to form water, combine with iron to form rust. Most elements hard to notice any differences in the physical or chemical properties of their isotopes. Hydrogen, though, is an exception. Hydrogen 1, no neutrons. Almost all of this hydrogen is hydrogen 1. Hydrogen 2, 1 neutron. Hydrogen 3, 2 neutrons. Because hydrogen 1 atom has only 1 proton, adding a neutron doubles its mass, which means its properties are going to change when you're doubling the mass. These isotopes also given names of hydrogen 1 is called protium, because it has is made up of a proton in its nucleus. Hydrogen 2 is called deuterium, because of the 2 particles in the nucleus, 1 proton, 1 neutron. And hydrogen 3 is called tritium. Most isotopes do not have special names. So, water that contains 2 hydrogen atoms in place of the hydrogen, or hydrogen 2 atoms in place of the hydrogen 1 atoms, we call heavy water. Hydrogen 2 atoms, about twice the mass of hydrogen 1 atoms, so the properties of heavy water are different from the properties of ordinary water. And we can see melting point changes, boiling point changes, and its density changes. And as always, a few quick review questions. Always good to think about these, try them, pause the video, and then see if you got the right answer. Which way do isotopes of an element differ? And in the number of neutrons in the atom. Isotopes have the same number of protons, they have the same number of electrons, and that charge on an atom is always 0, so that doesn't change for any atoms. True, false. Of the 3 subatomic particles that form the atom, the one with the smallest mass is the neutron. Hopefully an easy question for you. That's definitely false. It's the electron. So, that's it for today. Till next time.